Do you want to make sure you've understood what you've read? One of the best after strategies you can do for this is be the teacher. It's great for finding out what is still fuzzy for you and for remembering what you have read. Your job is to explain what you have learned to someone or something. Teaching a real person is best because he or she can ask you questions and push you to clarify what you are explaining. If you do not have a person to listen to you, use your imagination and teach your dog, a teddy bear, the mirror, or an empty chair. To gain the benefit from this after strategy, do more than retell what you have read. Watch what our reader is doing in this demonstration. You may hear her do some of these. The teacher makes clear her knowledge of the concepts. She explains the whys and hows of the concepts. She gives her own examples, predictions, and supporting ideas. She shares her opinions about the concepts, tells how she arrived at her answers, or gives valid arguments for her views. She helps the listener see the guiding principles behind the concept, problem, phenomenon, or facts. She uses her critical thinking abilities to discuss the concepts. She asks herself questions and tries to answer them.
Today in class, I learned about the Hammond postulate, which it was kind of cool because it just related all these different things together. But the main thing that I got out of the Hammond postulate, it talks about the energy states and how they relate to endothermic and exothermic reactions. So when you have an endothermic reaction, the reactant start at a lower energy state, and then the transition state is closer to the product. So it's gonna allow you to predict how the products will react how the products will finish with the starting reactants. On the other hand, when you have an exothermic reaction, as you can see here, the reactants are higher in energy, which means the transition state will also be closer in energy to the reactants. So the products will be different than how the reactants were. There will be a bigger gap in energy difference between the transition state and the products with an exothermic reaction.
Okay, so if I understand that right then, with an endothermic reaction, the transition state is closer to the products, the energy.
Right.
And then for the other reaction, the transition state is closer to the reactants, the energy level?
Right, yeah,
Okay.
that's correct. So for an endothermic reaction, the more stable product will form faster. So it's predicting what will form the fastest in the reaction.
Okay.
So because the products are so close to the transition state, that means that it'll form faster. So the stable your carbocation is, that means it'll form faster. Compared to an exothermic reaction where you don't really know what will form faster because the transition state is closer to the reactant. So the activation energy is similar for both the products. So in this example here, it gives the difference between the transition states and the carbocations. So you can tell that a more stable carbocation, if it's in an endothermic reaction, it'll form faster. As compared to if you have this more stable carbocation in an exothermic reaction, it may not or it may form faster. So that's kind of the ambiguous part with that.
Okay.
Does that make sense?
Yeah, I think I understand that.
Okay. As we're going on, in the SN1 reaction, the slower reaction will be with the less stable carbocation, and the more stable the carbocation will be, that'll be the fast reaction.
Okay.
Okay. This is one of the examples that we did in class, and I want to understand it better, so I'm going to see if you can understand it better.
Okay.
We have an alkyl halide here. We have CH3, so CH, Br, compared to a CH3, CH2Br, so CH, C. In here, which one would form faster in an SN1 reaction? So we have to look at which carbocation is more stable. Here, when this leaves, here, you'll have a CH and then that will be your carbocation there. So you have a tertiary carbocation. And
Okay.
here you have this one will leave there. So you'll have the C attached to all those. And then you'll have this one there. So it's also a tertiary, but because it's attached to this carbon here, it'll be more stable.
Okay.
So that will be the more stable carbocation. So in this instance, this one would be the fast reaction. Does that make sense?
Okay, and I'm just wondering, like, what is it about the extra carbon that makes it more stable then?
It has to do with the electronegativity of the atoms. And so with the electronegative pull coming from that carbon, it'll cause this to be more stable.
Okay, so it kind of like spreads that positive charge out
Right,
there.
yeah.
Okay.
So it can share with other things, with other parts of that atom.
Okay, that makes sense.
Well, we can do one more. Let me see if this one makes sense. So you have this chain here with the Br bromine, your leaving group. And then you have this one here with another bromine. So when this leaves, this will form a...
What does Be the Teacher do for you, the reader? It confirms what you understand. It points out where you lack understanding. It enriches your understanding because of what you bring to the explanation, your examples, your opinions, and so on. It deepens your understanding beyond stating the information in the text. It makes you consider the concepts from different angles because of the listener's questions. By explaining the concepts, you are learning the concepts. Some students name this as their favorite strategy because they become so aware of the depth of their learning and what more they need to learn.